All right, chapter 10. Everybody has chapter 10. Terry, can you put your phone away? Okay, so in this chapter, we're going to talk about the conic section. Conic section comes from the word cone. Does everybody know how a cone looks like? Yeah, like ice cream cone or like traffic cones. Okay, so these are cones that we're looking at. Now we are going to look at double cone. Double cone is something like this, like an hourglass. So there are two cones. And what we're looking at is if you were to cut this cone apart in certain directions, what would the cross section look like? For example, this first one, just ignore it. The second one, if you were to cut this cone parallel to the bottom of the cone, you cut it and then you look at it and you say, what kind of shape is this one? What would be that shape? Okay, so I want you to, everyone's, okay, so I want you guys to go ahead and draw out those shapes in that green box below. What would the 2D shape look like if you were going to cut it and then look at it? What would be that shape?
Like for the top or the bottom?
Huh?
Because like...
The shaded area.
Oh.
Yeah.
Okay.
Yeah.
Wait, 2D?
2D, yeah. If you look at a 2D shape, how does it look like?
This is 2D.
Alrighty. First one we're going to ignore. The second one from the left. What kind of shape is this one? Circle. Okay, not an oval, okay? You got to imagine it. This is a 3D. You're cutting it parallel to the bottom, so if you look at it, it's going to be a circle. Okay, so this one we're going to say circle. Next one. This one, you're cutting it a little bit slanted towards the bottom. So it's not parallel anymore, it's slanted. So if you look at it, what kind of shape is that? Oval, right? It's going to be an oval shape. Okay, in this chapter, we don't say oval, we say ellipse. E-L-L-I-P-S-E, ellipse. We don't say oval, we say ellipse. Next one. If you look at that shape, what is that shape? Not a triangle. Remember, your cone is circular. So, like, if you take this and then you cut it this way, slanted, and then you look at it, like if I had Play-Doh, I would show you. So you slice it this way, and then you look at it, what kind of shape is that? Cannot be a triangle because this is round. Looks like this, right? Right? Pretty much looks like that. Now, if I don't close this cone off, it would continue going down like that. What kind of shape is this? Think, yes, parabola.
What?
Last one. This is a double cone. I slice off one edge and then I look at it. So it's going to look like this, right? And again, what I'm going to do is not cover it off. So it's going to continue going on forever. What kind of shape is this one? It'd be crazy if you actually know the name. It's like a double, huh? Double parabola, right? There are two parabolas. So we don't call this parabola. We call it hyperbola because I guess there are two of them. So instead of parabola, we call this hyperbola. Okay, these are the four shapes we're going to study in this chapter. And we're going to have equations for all of them. And then we're going to move them around. We're also going to have a project. And it's really fun. And last year, we had a competition to see who had the best project. And I had all the teachers vote who was the best. And the best one got extra credit. So it's really fun. And people got really crazy. We were using these shapes to create things. And then people created like BB-8, Death Stars. And then they had like cars that move. It was just crazy. People went crazy with the project. So it's fun. So we're going to do that. Okay. Now let's talk about real life examples. What are some things in life that is circular?
Clock.
Clock, very good.
Soda can.
Cans. You and Sebastian think alike. Anything else? Circular. Basketball. Okay. If you cut it in half, I guess. Okay. All right. How about ellipse? So, huh? Eggs. Kind of. Huh? Plates. Okay, so there's some oval plates. Anything else that's elliptical? Huh? Huh? What?
Oh, he said donuts. No, you said donuts.
What? This is the cream-filled kind?
Yeah.
Oh, okay. Cream-filled donuts. Okay. Parabola. What are some things in life that's parabola shaped? It's a little harder. You guys are all smiling like you're thinking of something, just not telling everybody. Nothing? Huh? Hill? Okay.
A banana.
A banana? Okay. What else? Roller coaster, okay, yep. Some parts of it. Okay. Last one, hardest one. Hyperbola.
2 upside down camels.
2 upside down what?
Camels.
Camels? Camels?
Wait.
Camels.
Wait, what? Why does it only have 3 legs?
I didn't get to the other 2. Maybe not. Maybe not an upside down camel. Hourglass. Okay. Anything else? Can't think of any. How about lines on a basketball? All right. Huh?
Thinking outside the box.
Yeah, think outside the box or the cone. Okay, so in every one of these equations, eventually we're going to learn the equations. They're all going to have HK. HK always represents vertex or center, depending on what kind of shape we're looking at. Okay, so the next part, really easy, but you're also going to do this with your partner. Just in case you get stuck, at least your partner is here to help you. You are going to identify the shapes and then domain and range. Domain and range. Domain and range is a little bit tricky. Please work with your partner. What is the possible numbers of that shape? And sorry about that, there are some numbers that's hard to see. Like for example, this one. This is -8 and this is 8 on the hyperbola. And then on the parabola, it's 6. Sorry, -6. All right, let's start from the left this time. Chad, what shape is this one on the left?
Circle.
Circle? Okay. Trey, what is the domain? What are all the possible x values of this circle on the circle? Which x values cover the circle? I guess that would be a better question. Which x values?
0
Mm-hmm.
and 8.
0 to 8, right? So that would be 0 less than or equal to x less than or equal to 8. Okay, Andrew, you want to try range?
Sure. I put it, -6 is less than or equal to x.
Ooh, not x. Range would be.
Y.
Yes, very good.
Which is less than or equal to 2.
Yes, very good. All right, Terry. Shape, second one. Good. Nathan, domain. So what x values will cover this whole ellipse?
X is less than x is greater than or equal to -2.
Uh-huh.
And x is less than or equal to 2.
Good. And then Evan, the range? -1. Mm-hmm. Good. All right, next start with Andy in the back. Shape. Yeah, hyperbola. Sam, domain. You have the hardest one. No? Yes? Mark, you want to try it? No? Rula, do you have the domain? Yes?
Greater or equal to -8.
Positive 8, yes. So basically your hyperbola is going to exist on both sides. So it's going to be smaller or equal to -8 or bigger than or equal to 8. But it's on the two sides. Nothing in the middle. Hyperbola is not existing in between -8 and 8. Oh, Alice, range, you want to try it? Yes, very good. All real numbers. Okay, everything. The hyperbola is going to go on forever. Daniel, last one, shape.
Parabola.
Good. Okay, Brady, domain.
-6 is less than or equal to x.
Yes.
Good job.
Okay, Sally, range. Yes. All right, so that's that. So this is pretty much the first section. Since you're going to take a test on Wednesday and then Thursday is going to be test correction, we're going to start the parabola stuff today. That way we don't have to cover so much on Thursday. Next section. So every section we're going to cover one conic section, and then the last section we're going to move them all around. Okay, so the first one, parabola. Parabola, by definition, is set of all points that are the equal distance from a fixed point, and that fixed point is called focus, F-O-C-U-S, as they are from any point on a line, and that line is called the directrix, D-I-R-E-T-R-I-X. So just write that down first, and then I will show you what that means. Parabola is defined as a set of all points that are equal distance from a fixed point. That point is called the focus, as they are from any point on the line, and that line is called the directrix. Okay, so we are going to look at two kinds of parabola. One goes up and down, the other one goes left and right. You already learned parabola in chapter 4. We're going to look at all those parts again plus some. So let's look at this parabola. This dot here, this black one here, what is the name of this dot? Yep, vertex. What are the two letters that represents the vertex? HK, very good. Now this line that cuts the parabola in half, do you remember what that line is called? Huh? The what? Yes, axis of symmetry. Okay, let's see if you remember the equation of this line. Now, it's not very hard to find the equation of this line. Just think about it a little bit. Is this line vertical or horizontal? Vertical. Vertical lines always have an equation that starts with x or y? X. X, right? Now, this x has to cut through the x part of the vertex, so it has to be h or k? H. So this is x equals h. Okay, let's look at some new things. This point that's inside the parabola. This point that's inside the parabola. This one has a name. It's called the focus. The focus is always inside the parabola. Okay, you have this orange line that's outside of the parabola. That is called the directrix. And the directrix is always outside the parabola. All right, now the distance between the focus and the vertex to the directrix is fixed. This distance is called c, and it's always c. Okay, the distance between the focus and the vertex is c. From vertex to directrix is also c. Okay, I'm gonna need your help to think about this conceptually. So I'm gonna force your mind to kind of think outside the box a little bit. So stay with me, especially if you're not really sure how to do it, just say some answers anyways. It's better if you think about it and say the wrong thing than not think at all. Okay, so vertex, HK. Whoops. Vertex is HK. Now, what does H represent? X or Y? X, and then K represents Y. Okay, so that means from the origin, I'm going to go towards the right, H, go up K to get to the vertex, right? Yeah, that's how coordinates work, right? X first and then Y. To get to the focus, do I go up or down? Up. If I want to move up from the vertex, do I move H or K? K. Why K? Because it's Y. So what do you think is the coordinate of the focus? Terry, are you with us?
Yeah.
Come back with us. Okay, so what do you think is the coordinate in terms of HK and C for the focus? Very nice. Yes, that's correct. So, to get to the focus, we first get to the vertex, H. And then what I do is I go up K, but then to get to the focus, I need to go up a little bit. I need to go up C more. Are you guys with me? Yeah? Okay, so this is how you memorize all those equations on your paper. You just draw a picture and then just memorize it that way. Or else it's just impossible, too much information. Now, if you want to get to the directrix, first you get to the vertex, and then how do you get to the directrix? Do you go up or you go down? Down. Down by how much? C. If you're going to go down C, do you add C or do you minus C? Minus. Minus C from what? H or K? K. Why K? Because it's Y, right? Okay, now if you look at the directrix, is it a vertical line or a horizontal line? Horizontal line. So horizontal lines always start with equation of Y equals. So what do you think is the equation of the directrix? Not H. k, because we're moving the y direction, k minus c. All right. Okay, so now what I want you to do is fill in all that information for the parabola on the right. So you're going to write down where the vertex is, label your HK, where the focus is, where the axis of symmetry is. Whoops, symmetry. Directrix, and where C is. All right, let's label all the parts. This is the vertex, and vertex is always HK. This is the focus. This is the directrix. Axis of symmetry is this one. And the last thing is C. C is this. Okay, so now let's look at the focus again. To get to the vertex, I go HK. This time, to get to the focus, do I go right or left? Right. Right by how much?
C.
C. So should I move H or K?
H.
Very good. So then what would be the coordinate of focus? H plus C, comma K. H plus C, comma K. All right, same logic. Let's go to the directrix. I am at my vertex, HK. Now, for me to go to the directrix, do I move right or left? Left by how much? C. So which one do I move? H, very good. So then is it H plus C or H minus C? H minus C. And then this is a vertical line. So vertical lines have is it x equals 2 or y equals 2? X equals 2. H minus C. All right, let's write down all that information down here. Vertex HK. Focus for the one on the left is H comma K plus C. Directrix is, that was a horizontal. So horizontal is y equals 2, K minus C. And then on the one that goes left and right, vertex is HK. Focus is, we're moving left and right, so H plus C, comma K. Directrix is x equals 2, H minus C. Are you guys good so far? Yeah, not too bad. All right, next. Now let's remember our vertex form of a parabola. What is the standard vertex form of a parabola? It has to do with A, H, K, and something squared. A, yeah, A and then something squared.
X squared.
Ooh, so close. What about H and K?
No.
Yeah, x minus H squared plus K. Now, if you look at this parabola here, there is no A. So we need to redefine A. A is 1 over 4C. Okay, this you have to memorize. If you don't memorize this, it's impossible to figure out this parabola. You could figure out C, you can figure out H and K, you just cannot know that A is 1 over 4C. So you have to memorize this. Okay, so this is really our new parabola equation, 1 over 4C times x minus H squared plus K. This is the up and down parabola. We're going to now go left and right. You've never seen left and right before because it's not a function. Remember, how do you make things a function? How do you know if something is a function? Vertical line test. So this left and right parabola is going to fail, right? So it's not a function, but we still want to kind of investigate it. So we still have an equation for it. Now, because it's left and right, all of my x, y switches, all of my hk switches. So it's going to start with x. X is equal to 1 over 4c times. What do you think is going to come first? Kind of look at the previous equation, all your xy switches, all your hk switches. Not x, y. Y minus k squared, and then plus h. Okay, so make sure you switch x and y. Make sure you switch h and k. That's a lot of info. Last thing. Direction. On the left and right parabola, when A is positive, which direction does the parabola point? When A is positive, up. So when A is positive, it points up. And then when A is negative, it points down. Now, if you look at the one on the right, it's the same thing. If it's positive, it's going to point towards the right. If it's negative, it's going to point towards the left. Okay, we probably have time to solve one question and let you practice one, and then we are good. Sorry, just a few notes here. Focus is inside the parabola, and then directrix is outside. So just a note for yourself. It's going to help you a lot. Focus is always inside. Directrix is always outside. Okay, let's look at one question. Write an equation of the parabola with the vertex at the origin and focus at 0, 2. Okay, just draw the picture first. Label vertex, label focus. So what I usually do is V for vertex and F for focus. Okay, draw just a general shape of this parabola. And then we're going to figure this out together. All right, so let's take a look. Vertex is at the origin. Focus is at 0, 2. So which direction does this parabola point? Up. How'd you know? Yeah, because the focus is inside. Now, it really doesn't matter how we draw it. We just want to know what direction. How big is C? 2. How'd you know it's 2? Because the distance between F and V is always C. Right? So C is 2. Okay, so let's write down all that information. So what's HK? 0, 0. Okay, and then we know that C is 2. All right, this is a lot of analytical skills just to solve this problem. So you got to think back and forth a lot. Parabola. So this is an up and down parabola, right? Which equation would that be? Is it an x equals 2 equation or y equals 2 equation? X. Right? Wait. Y equals 2. Y equals 2 equation. And so what we want to do is just write out the skeleton of the equation. 1 over 4c times x minus h squared plus k. Okay, you have all the information you need to plug in and figure out the equation of the parabola. So go ahead and do that. Plug in everything we know. So y is equal to 1 over 4 times 2 times x minus 0 squared plus 0, which is 1 over 8x squared. Good? Okay, let's try another one. And this will be the last question today. Write an equation of the parabola with vertex at origin and focus at -1, 0. Okay, again, draw a picture, vertex, focus, and then figure out which direction this parabola is going to point. All right, I'm going to help you out a little bit. Okay, so the vertex is at the origin, focus is at -1, 0. This is going to point this way. So first of all, what value is C? Okay, so this is what I do. I always make it positive because I will figure out whether it's positive or negative based on which direction it turns, or else I'm going to get very confused. So I always just make a positive number. This is a left and right parabola, right? So which equation are we going to use? The x equation. Okay, 1 over 4c times y minus k squared plus h. Okay, one last thing to be careful on. Which direction is this pointing? Left. So is it a positive or a negative parabola? Negative. Okay, so please be careful on that. Okay, so x is equal to -1/4 y squared.